It actually does come from the French word for mountain, so I've been told. But we use M for too many other things, so I'm going to just put a $ here to represent the slope instead of the M. I'm going to take our equation over there and put it in this form. So A, that's my vertical there, is equal to 1 over M, the mass, times the force, plus 0. So what I'd expect is that my line is going to go through the origin. My intercept is 0 means it's going to cross the y-axis at 0. And the number in front of my force should be 1 over my mass. Came close to hitting the axis at the origin there. My slope is rise over run. And so my rise here, if I'm going from this point to this point, that's roughly 0.1. So my rise is about 0.3. And my run is going from 0.1 to 0.3, so my run is 0.2. Any questions about how I got rise and run of 0.3 and 0.2? So I have a slope here of 1.5. From this, what I had over here, my slope should be 1 over the total mass. So slope should be 1 over the total mass. So based upon this, the mass is, so I got 1.5 is equal to 1 over the mass. So the mass is equal to 2/3, or 0.667 kilograms. That's my prediction based upon my crude drawing. The actual mass is on the board somewhere, or did I erase it? I did erase it. What was the actual mass? We can figure it out again if we have to. 0.58. All right, so 0.58 kilograms was our experimental mass, well, based upon memory and trusting the manufacturers. And our prediction was this. Not great results, but then again, a lot of crude estimates. So let's do this slightly differently. We'll go back to the drawing board here. All right, so we have force and acceleration. My force is, we had 0.196, 0.392, 0.49, 0.686, and acceleration of 0.30622, 0.47334. 79984, 1.13. Oh, what the heck? Let's put units in here. And insert chart. One of those points is not like the others. And add a trimmed line. And 4 portions. And I want to display the equation in the R squared line. So we have a different slope there. We have a slope of 1.7447 if it had been done on a graph on like this. I know right now this is not particularly important, but this is bugging me, and chalk it off to my obsession sometimes. Acceleration versus force. This is acceleration. Really don't need a legend here. And the trim line's gone. All right, so there we have a graph. Let's shift this so it can be seen more easily by the person reading it. And all right, assuming I spelled everything correctly, there's a proper graph. We have a slope now that is different than what we had done with the crude drawing. This is obviously more accurate than what I had done, which is one of the reasons why I really like people using the spreadsheet as opposed to doing it by hand. But we have a slope of 1.7447. By the way, what would be the units of the slope? I know you're enthralled and it's just difficult to speak after just the excitement that you felt, but try to break yourself out. What would be the units of the slope?
Meters per Newton?
Is it meters per Newton?
Yeah.
You'll have something now.
Is it
Meters per second per Newton?
Say it again?
Meters per second per Newton?
Closer.
is it meters times newtons over seconds squared? Wait.
No, that wrong placement of the Newton. I'm thinking I heard some voice over there who say it.
I said meters per second squared times
What are you multiplying times the Newton?
the second squared.
Yeah, that's it. So the units would be meters per Newton second squared, or second squared Newton, the way Emily had said it. So that's the unit right there. It's an awkward unit. It can actually be simplified into 1.7447 1/kilograms. All right, because I know that the slope is the reciprocal of the mass, and the mass is in kilograms, so the slope better be in units of the reciprocal of kilograms. All right, so what is the actual predicted mass given this graph? So in so my mass should be 1 over that slope.
Plus, so that's your mass?
The mass should be the reciprocal of that number right there. And if someone would be kind enough, this is our experimental mass. 0.58 exactly. 0.5721. 31. 0.5731 kilograms, and what we had crudely come up with was 0.58 kilograms. Pretty darn good. Our intercept here, can't quite see it, that's a negative sign there. I'll just double check to make sure that's not a blurry plus sign. Yeah, it's a negative sign. Is some indication of sort of errors in the lab, intrinsic errors in the lab. Whatever happened with that trial right there, does seem to be something wrong with that trial.
That was before you messed with the wheel again.
That's right, we didn't redo that one. But, so, one thing we're doing is the trend line is supposed to be an indication if everything done perfectly, everything falls on the trend line. It also quickly shows data points which seem a little bit off, like that one right there. And that's also, that point right there is also bringing it from hitting the origin, it's bringing it down. Actually, in reality, I would not expect it to hit the origin, I would expect it to hit a little bit off of it because we did not take friction into account in terms of the total force. Questions?
So what does this tell us about the whole situation?
What this tells us is that, in fact, there does seem to be a relationship between acceleration and force, that we used Newton's second law to predict that the slope would be the reciprocal of the total mass, and we were off by under 2%. Now, when students do this lab, the biggest mistakes is they forget to multiply that coefficient by 2. The other one is they find the acceleration by taking the force and dividing by the total mass, so they got perfect results. And the other, another mistake is flipping the axes.
Wait, why is it bad to divide the force by the total mass?
Because now your experimental acceleration is based upon theory. We're testing to see if the theory is true or not. So that's why we have an experimental force, we have an experimental acceleration. I don't want to use theory in order to predict that the theory is true.
Okay.
I also want to point out that I noticed on the graphing lab, when asked what is the slope, some people gave me the entire equation. And just please note that the slope is just the number right here, not including the x, just the number right in front of it. That's the slope. And for the most part, I think there was one, two, maybe two people who had the axes backwards. That was encouraging, that there were only two there, so just please be careful about that. The biggest other big mistake is I saw a number of people decided to go freelance on the title of the graph. In the lab itself, it said plot, I forgot what the graph, oh, it's right, plot bounce height versus drop height. When I say plot and then I give you something, that is the title. Plot height versus drop height is the title of it. And it should always be the dependent variable versus the independent variable. And I think on that note, we've got I guess the test is next Tuesday. The quiz on 4 and 5. We can ignore the quiz on 4 and 5, the one from the textbook. The plus is you can spend your time studying something else. The minus is there's one fewer grade in case you have a bad one. It waters it down the more quiz grades you have. And for some people it's forced studying. So the question is, do you want to do the quiz on the textbook problems from 4 and 5? And what makes sense would be on Thursday. Or I've also done quiz and test on the same day. We can do it Tuesday, next Tuesday also. Okay, so no to that.
Next Tuesday for both.
What's that last one?
I don't wanna take the quiz and the test on Tuesday, I vote against that.
Okay. You sound pretty adamant about it. But the rest of you are gonna say, listen, you're not my boss, we're gonna do it just to spite you.
Okay.
All right, so I guess the option is no quiz, quiz on Thursday, or this is for 4 and 5, or on Tuesday. It sounds like that's not a favorable thing.
If we do like no quiz, can we still get it to practice at home?
I mean, it's just textbook problems, so I mean, you've got the textbook problems already.
Yeah.
Maybe I'll
So Bill, you were voting for, well, why don't we just do straight up vote?
Would this be optional? Do you want to take it?
I don't know. I've done optional before. I've done it where optional, but if you do it, it's gonna count. And then it's usually, I've done that later in the semester where people are desperate, and the desperate people usually don't do well.
But we're not really desperate right now.
Yeah, that's why I was curious about what would happen if we made that optional. When would people take it? What are you suggesting people would take it if? Oh, you haven't gotten that far? All right.
You want hands raised for Tuesday, hands raised for Thursday?
All right, so we got Thursday quiz, next Tuesday quiz with test. I mean, you would do the quiz and then you would do the test. You could take a break in between. And then,
No quiz? No.
that's right, no quiz. Just for the sake of ease, I'm gonna say, I'm not gonna do the optional one. But if you desperately want to do it because you want that extra grade, talk to me individually. So I guess if you're doing optional, if it doesn't get, if no quiz gets voted, talk to me if you still wanna do it. That's how we'll do optional. Then we'll arrange a time. All right, so quiz on Thursday. Oh, okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I got, I think there was 10 there. Tuesday quiz. Looks like they all agreed with you. No quiz. All right. Quiz on Thursday. I was surprised by that, but oh, stop the hand back. No, officially it's last time.
You want me to stop the recording?
Yes, please. Sorry, I accidentally flashed the grade.
Yeah.